Hey folks, second part. It's more of the same, you guys. So a quick recap for two sample t-test are conditions that are the two population standard deviations are not known. The samples are random. The samples are independent. Excuse me. And either the populations are normally distributed or both sample sizes are greater than or equal to 30. Okay, and so it depended on whether the variances were equal. We do this times this with degrees of freedom of the sum of the two minus 2. So n1 plus n2 minus 2. And if the variances weren't equal, these are just the denominators. So that would be this, and then so we're going to crank those out and put it in the denominator. So sample mean 1 minus sample mean 2 minus, this is always 0 because we assume that the null has the equals part in that, so when you subtract the equals, then it's going to be 0. Okay, let's just do one example. So a manufacturer claims that the mean operating cost per mile of its sedans is less than that of its competitors. So you conduct a study using 30 randomly selected sedans from the manufacturer and 32 from the competitor. So those are both greater than or equal to 30, so we don't have to worry about the word normal in this. Okay, so the results are shown below. So at the 5% significance level, can we support the manufacturer's claim? Assume the populations are equal. Okay, so let's go ahead and state, you guys. So some of you guys still aren't writing this down, so you need to state that are the population standard deviations are not known. The samples are random. It said that the samples were random right there, randomly selected right there, and independent of each other, okay? Because one's from one company and one's from another company, okay? So we can use a t-test, all right? So the claim is that the mean operating cost per mile of the manufacturer's sedan is less than that of the competitor. So that's going to be our alternative. This one's less than that of the competitors. That's our claim. So the null is greater than or equal to, okay, so that the mu's are, okay. So the population variances are equal, so our degrees of freedom is n1 plus n2 minus 2. So we get 60 on that, okay. So because it's a left tail test with degrees of freedom of 60, a one tail test with degrees of freedom of 60, look up the 0.5 and go down to df of 60. And then you should see a negative 1.671. So our t-score, if we get a t-score that's to the left of that, then we can reject it, okay? All right, so here we go. So find the standard error. That's our denominator right there. We're going to use that formula. So this is the sample size. So this is going to be 30 minus 1. So I'm just plugging in these. And here's the sample standard deviation. So this is going to be 0.05 squared. Over here it's going to be 32 minus 1 plus 0.07 squared. Over here we're going to divide it by 60. Square root that, and then here this is 1 over 30, 1 over 32. It's our sample sizes. Add them together, square root that. Okay, so we're going to get about 0.0155416. Okay, now we did this actually in the calculator. You go to stat and then test, and then you scroll over to test at the top, and I think it's number 4, a two sample t-test. So it gives us a little bit different t-value, but it'll still give us the same results at the end. So our standardized test score, so we're going to subtract the means, 0.52 minus 0.55 minus 0. Going to put this in this denominator right here, okay? So when we do that, we get about negative 1.930. Now the rejection is if it's less than negative 1.671. Okay, well that is less than that. That is in the rejection region. So here it shows, always draw the curve, you guys. So the curve has 0 in the middle, and then 3 standard deviations that way, and 3 standard deviations that way. Okay, so if this is negative 1 and this is negative 2, so negative 1.67 will be somewhere around there. So since negative 1.930 is in this rejection region, then we can reject the null hypotheses right here. And what does that mean? Don't just say we can reject the null hypotheses. Always interpret it with the context of the problem. So here there's enough evidence at the 5% level of significance to support the manufacturer's claim right here. Sorry about that. That the mean operating cost per mile of on the sedans is less than that of its competitors. So I'm doing this on break, so it's going to ring again pretty shortly. Okay, So my kids, I had to go to a meeting today, so I'm going to take that off. We don't need that anymore. But that is our assignment right there. Okay. All right. Take care.